Hello everyone, my name is Kaylee. Today I'm doing my exam video on a pedigree of the show Friends. So here's our pedigree. We have 3 generations and every single character has their name beside them, so if you wanted you could go and look to see who's who. So as you can see below the pedigree, we're trying to find the mode of inheritance of our trait. The individuals with the phenotype for this trait are shaded in on the pedigree, and our trait is the tendency to get divorced, which we know is not actually genetic in real life, but it works well with the show. So the phenotype for this trait is the person that seeked out a divorce. So anyone that divorced their partner. You can see that both Jill, Ben, and Emma all have question marks instead of being shaded or unshaded. This means that they never got married, so we don't actually know their phenotype. So moving on, we're trying to find the mode of inheritance. Let's start with X-linked dominant. So when taking a closer look at the pedigree, we can actually see that it's not possible for this trait to be X-linked dominant because, as you can see, Jack and Judy Geller would both have to have the recessive trait, but their son, Ross, would have to have the dominant trait. This is, of course, because Jack and Judy don't show the phenotype, but Ross does. So now we're seeing if the mode of inheritance could be X-linked recessive. Let's take a closer look at the cross between Leonard and Sandra. So Leonard does not show the phenotype, so he would have to have a dominant allele. However, both Sandra and Amy Green show the phenotype, so they'd both have to have the recessive alleles on both X chromosomes. This isn't possible because the daughter gets one of her X chromosomes from her father, and the father's only X chromosome has the dominant allele. So now we know that it can't be X-linked recessive, so we're going to see if it could possibly be autosomal dominant. Well, if we look between Jack and Judy, they had Ross, so both the parents are unaffected, but the child is, so it's not possible for it to be autosomal dominant. So it's not autosomal dominant. Could it be autosomal recessive? Well, I went ahead and filled out the genotypes. For anyone with the phenotype, it would have to be homozygous recessive. No immediate contradictions here, so we'll go ahead and continue filling out the pedigree. So now we've filled out the whole pedigree as if it were autosomal recessive, and there isn't anything that says otherwise. So yes, it could be autosomal recessive. The next mode of inheritance to test is Y-linked, but we already know it's not Y-linked because there are females with the trait. So we've gone through and tested each mode of inheritance, and the only one that we have not been able to rule out is autosomal recessive, so it's safe to say that that is the mode of inheritance for this trait. And here are my sources. I'll also be including the links in the description. Thanks for watching.